Hi, I said I was going to make one last quick video for the final thing in 8.2, and that's a question about what if we don't actually know the sample size yet, because we haven't done our sample, and we want to create a sample size that gives us a specific margin of error. What if we want to work backwards? Sometimes we want to choose a sample size that allows for a certain margin of error. So our margin of error, remember, is a critical value, z star, times the standard deviation of our statistic, or in this case, the standard error of our statistic. And the question here is, if I want a certain margin of error, what should my sample size be to make that true? And if we are doing this, we have not created a sample, which means we don't have a statistic yet. We don't have a p-hat. And so there are two methods for choosing the p-hat. The first would be use a previous study. Previous study statistic. So either one that you did or someone else did. And the other option, if you don't have a previous study to draw on, is to use 0.5 as your p-hat. This is going to give us the largest possible margin of error for that sample size. And then you set up an inequality and solve. So z star times the square root of p-hat times 1 minus p-hat over n. And if we want a specific margin of error, we say that is less than or equal to the margin of error that they give us. We set this up and then solve for n. So let's see this in action. Suppose you wanted to estimate p, the true proportion of students at your school that have a tattoo with 95% confidence. I'm actually kind of interested in this. With a margin of error of no more than 0.10. I don't want to be more than 10% above or below my guess. So determine how many students should be surveyed to estimate p within 10% with 95% confidence. I know that I need to set up the following inequality. I know the margin of error I want is 0.10. Is going to be less than, or excuse me, oh goodness, why is that over there? Greater than or equal to, I don't know my p-hat. We are estimating p. We don't have a previous study that they give us, so we're going to use 0.5. N is the thing we're solving for, so that stays a variable. Square root of that thing. And then I need my z star critical value. So if I want 95% confidence, I believe we just found that in the last example, right? This one was 95% confidence. So I'm going to actually just go back and look to see, oh, 1.96. So 1.96. I have set up my inequality, and now this is really just algebra. Not saying it's easy algebra, but that's what it is. We're solving for n. I would start by dividing both sides by 1.96. So I have the square root of 0.5 times 0.5, which is 0.25 over n is less than or equal to 0.10 divided by 1.96. I don't even need to know what that is right now. To get rid of my square root, I am going to square both sides. So then I have 0.25 over n is less than or equal to, if you want to pause the video and try and type that into your calculator, you can. Otherwise, you should get a decimal, 0.0026. From here, I would probably multiply both sides by n, and then divide both sides by this 0.0026. So your final inequality is that n is greater than or equal to 96.154. So our final answer would be, we want to sample at least 97 students. Why did I round up? Well, of course, I can't have 0.154 of a student, and if our sample size needs to be at least this big, then I need 97 full students. that is the rest of our 8.2. So thanks for following along.